Every physical object you interact with has weight, mass, inertia. But when we look for the mechanical origin of that mass, standard physics runs into a glaring mathematical deficit. If we isolate a standard proton, experimental measurements show it has a mass of approximately 938 mega-electron volts per speed of light squared. Under the Standard Model, the Higgs mechanism assigns mass to the intrinsic building blocks inside this proton, the up and down quarks. This block graphic represents the total 938 MeV mass, but that tiny sliver at the bottom represents the combined mass of the up and down quarks, roughly 10 MeV. Over 99% of a proton's mass does not come from the intrinsic mass of its constituent particles. Orthodox physics attributes this massive remainder to quantum chromodynamics, specifically to strong force binding energy. This is modeled mathematically as gluon field energy, populated by virtual quark-antiquark C excitations. The Standard Model successfully calculates this energy value, yet it fails to provide a deterministic mechanical foundation for what physical substance actually stores it. In traditional QCD, this confinement energy relies entirely on the behavior of fluctuating quantum fields. These fields are theorized to fluctuate within an otherwise empty vacuum, an environment entirely devoid of physical mechanical structure. In classical mechanics, energy storage requires a physical medium undergoing strain or motion. You need a spring to compress or a fluid to pressurize. Tension requires a structure to strain. Explaining mass through virtual particles bubbling in and out of existence mathematically bypasses this requirement, leaving the actual mechanism highly abstract. What if this binding energy is actually a literal mechanical tension? The elastic continuum theory provides a deterministic solution to this exact gap in modern physics. To locate the missing 99% of mass, we have to stop treating matter as isolated points in empty space and begin analyzing the structural integrity of the vacuum itself. The foundational axiom of the elastic continuum theory states that the vacuum of space is not empty. We define this surrounding vacuum as the plenum, an infinite hyperelastic solid that completely permeates all of physical reality. In this model, matter does not consist of independent, point-like objects resting inside a void. Instead, a fundamental particle is a localized topological knot, scientifically termed a soliton. We map this stable knot using the displacement field, represented by the vector u mu. These arrows point from the plenum's undisturbed baseline intersections to their newly deformed positions. Pulling any hyperelastic medium out of its baseline state requires energy, and the medium naturally resists this deformation. Because the soliton is stable, it does not unravel. The elastic strain energy required to create it is locked permanently in place. A particle is merely a geographic location where the vacuum lattice has been folded and locked, storing vast amounts of potential energy in the strain. This vector Giorgiotti's master equation calculates E, total energy density of a deformation. The kinetic term relies on rho zero, baseline density. Cijkl represents elastic moduli, measuring resistance to twisting. Finally, the sine-Gordon cosine function creates steep potential wells, locking the displacement field stably. The scaling factor, chi, renormalizes these macroscopic elastic mechanics down to the quantum scale. This equation translates abstract quantum field energy into a rigorous, deterministic calculation of volumetric elastic strain. We can now apply this logic to composite structures, specifically the proton. A proton is made of tightly bound quarks. In this theory, those quarks are distinct subsolitons. This brings us to equation 2. Here, West mass, m0, is derived not as a static property, but as the volume integral of the localized potential and strain energy. We integrate across the entire spatial volume, V, of the composite soliton to find true mass. Observe what happens mechanically when multiple subsolitons, the quarks, are forced into the extremely small confinement radius of a proton. Their local deformation fields do not just add up linearly, they overlap and non-linearly superimpose. Recall the steepness of the cosine potential well we mapped earlier. Because of that incredibly steep well, forcing these topological nodes together requires an immense amount of elastic work. Mathematically, this vast amount of required mechanical work directly translates to the massive integrated value of m0 c squared. This perfectly resolves the proton mass anomaly. The missing 99% of the mass is exactly this mapped mechanical work. This energy is not an abstract statistical fluctuation of virtual particles. The energy is entirely real, physical, and highly localized in the twisted solid medium directly surrounding the core. Quantum chromodynamic binding energy is simply the measurement of physical torsion within the hyperelastic lattice of the plenum. Rest mass is not inherently a product of the Higgs mechanism, nor is it an intrinsic property of a point particle. Mass is strictly a measure of physical geometry and tension. Mass is simply the measure of how severely the solid vacuum of the universe has been forced to fold.